Good morning, welcome to
KidMath number 19.
KidMath number 19, and this problem is based on an old math contest problem you saw this weekend at your math club, and just by coincidence what we've been studying with, similar to what we've been studying with quadratics. So I made up a new problem, and why don't you explain how to look at this? And then I'm going to talk about a different way. Two whole numbers add up to 12 and multiply to be 32. What is the positive difference between them? Okay? How would you think about this problem?
Well, we can factor 32.
Okay.
We have 1 and 32, 2 and 16, 3 doesn't work, 4 and 8, and then that's all.
Okay.
Then we need to sum these up to see which ones are 12. 33, 18, 12.
Okay.
So we have 4 and 8, and we need the positive difference, so 8 minus 4, which is 4.
Okay, good job. High five. All right, but we can also think about this like quadratics, as we've been talking about sums and products of roots, right?
Yeah.
So we have rs by two roots. The product is 32. The sum r plus s is 12. Now, what's really cool about math is this is going to be a completely different way to solve this. Okay, we're trying to find r minus s. Let me erase over here. R minus s. And here's an interesting relationship between r plus s and r minus s. R plus s squared, when you multiply it out, r plus s times r plus s, r squared rs, rs, s squared, r squared plus 2rs plus s squared. R minus s, r minus s times r minus s. You do the same thing, you get an r squared minus rs plus s squared. Why is it plus s squared?
Because minus times minus the plus.
Okay, r squared minus 2rs plus s squared. The difference between these two, this minus this, is 4rs. Okay? So in just an algebraic equation, r plus s squared minus 4rs equals r minus s squared. Okay? Sorry, I have to erase. And what's neat about this is we're going to solve for r minus s squared without even knowing what r and s are. Okay, r plus s squared, 12. What's 12 squared?
12 squared is 144.
144 minus 4 times 32. What's 4 times 32?
It's 128.
Minus 128. Maybe I'll do it this way. Okay, what's 144 minus 128?
20 minus 4, which is 16.
16 is r minus s squared. Now, so what could r minus s equal?
It could equal 4 and negative 4.
Plus or minus 4. Either one would work.
It says positive.
But we want the positive. So we can solve that r minus s is 4 without solving for what r or s is. So it turns out there's an amazing mathematical relationship between r plus s and r minus s. And that's why we had to specify the positive difference here, because there's two different possibilities. In other words, the answers are 8 and 4, so you can do 8 minus 4 or 4 minus 8. And either way you get plus or minus 4. Now, you might think this is just kind of an interesting curiosity, but not all that interesting. Do you think that? Do you?
Sort of.
Sort of, yeah.
It looks like a normal quadratic.
It does. It looks like just a bunch of algebra gibberish, actually. But there's been some amazing physical things that have come out of equations like this, including things that have plus and minuses. So I think in the 30s, I don't know the exact date, there was an English physicist named Paul Dirac, and he was studying the electron. And he noticed his equations had two solutions, pluses and minuses. And he said, there must be the equivalent of a negative electron. And he called it an anti-electron, I think, and it later got named a positron. And you know what happened?
What?
Some people actually discovered it later on. So Dirac said, according to his equations, these positrons must exist, but nobody had ever seen them before. And so they said, well, wait, it can't be true. But it turned out to be true. And it's happened a few other times as well, where math equations and relationships that just look like they're algebraic relationships have produced things that in the physical world no one had ever seen before. So it's pretty amazing. This is a simple example. But Paul Dirac, you ever heard his name before?
No.
I have a couple books about him, but they're not on camera. So I thought you might like to see that. Math can be very powerful. The powerful thing about this is we solve for r minus s without even knowing what r and s were, right?
Yeah.
Okay. Good job, Steve. Sorry that was a little long today.